So polynomial function graph, how we're gonna graph the polynomial function, and we're gonna do the steps. I'm gonna tell you where is the important thing. So you have to do step by step. The first thing, the polynomial function. This is the general form about the polynomial function. P of x, a n x to the power n plus a n minus 1, x to the n minus 1, plus until a naught. And here's examples about the polynomial function. P of x like 3x squared plus 4x plus 3, or P of x equal 4x cubed plus 5x squared minus 2x plus 4. So this is kind of the polynomial function. Now, today we're going to learn how to graph it. You have to do these steps, and you will see we're going to do examples about how to graph the polynomial function. Step 1, always you have to make sure to factor the polynomial. We already know how to factor the polynomial function with degree 2, and we're going to learn more methods about how to factor on polynomials, because this is really important. I told you before, is going to be a step here. So we have sometimes the polynomial they're going to give you, it's already factored. So you have to go to step 2. But if it's not, you have to factor the polynomial. Even if you take another math class like 14, you're going to go deeply about how to factor the polynomial with degree 3 and 4 and 5. Now, step 1, you have to factor the polynomial. Step 2, find the x-intercept. How are you going to find the x-intercept? We already learned that by letting y equal 0. We already took examples about how to find the x-intercept by let y equal 0, and find the y-intercept by let x equal 0. So we have 2 points from step 2, which is really important, these 2 points, because it makes my graph easier. Step 3, find the end behavior. With step 3, to find the end behavior, we have 2 options. Depends these 2 options about the n. N is the large exponent. Keep this one in your mind. What's the n? N is the large exponent. So we have 2 options. If n is odd or n is even. So let's check if n is odd. If n is odd, we have 2 options. The first option with the end behavior, if a is greater than 0, what's the meaning of the a? A is the coefficient. A is the coefficient with the large exponents. We will see that in an example. If a is greater than 0, the end behavior of my graph, this side, the right side is going to be up, the left side is going to be down. If a is less than 0, that's mean negative number. So this side, the left side is going to be up, and the right side is going to be down. We will see that in an example. Let's do an example here on the side, so it's going to be easier for you. For example, if we have 3 p of x equal 3x squared, let's do it to the power 4, minus 3x cubed plus 4x. So now n equal, n is the large exponents. So I'm going to check. Let's do it to the power 5. N is the large exponent, which is 5. 5 is odd. So now the first thing I locate is n is odd number, which is the large exponents, 5. So I'm going to put this one on the side. Now, I already know which side I'm going to work. I'm going to work with the n odd number. I have 2 options. Now, a equal is the coefficient here with the large exponents, the number here. The number here is 3. 3 is greater than 0. That means I'm going to work with this side. 3 is greater than 0. That means when I'm going to graph my function, when I'm going to graph this function, I already going to know the end behavior for the function from this side up and from this side down. Because my end behavior says the right side for the end side of your function is going to be up, and the end side from the left side from your function is going to be go down. It depends about this one. This is just, we will see that when we do examples to graph the polynomial function. Let's check another example. If we have this function, p of x equal negative 2x to the power 7 plus 5x plus 3. So now we have to check the end behavior. Now, the large exponent is 7. So I'm going to write down n is 7. N is 7 is odd number. That means I'm going to work with this side, the odd side. N is odd number. Now I have to check the coefficient A. The coefficient A, which is the number here with the large exponents. So that means it's negative 2. It's negative number. N is odd. A is negative. Negative 2 less than 0. That means I'm going to work with this side. Negative 2 less than 0. So my end behavior, when I graph my function, this side, the left side is going to be goes up like this. And the right side is going to be goes down. So this is the end behavior when you have an odd, n is an odd number, and when the coefficient A is a positive, greater than 0, the end behaviors look like this. When the n is odd number also, but the coefficient A is negative 2, which is less than 0, the end behavior is going to be like this, exactly like that. Sometimes when you're doing the homework, they're going to ask you only about the end behavior. So this is the first part here. Let's do the other part when n is odd. So I need to write down these examples. We're going to do more examples about that, about the end behavior. Let's do an example about when we have n equal an even number. We're going to do exactly the same thing. When n is an even number, so we have also two options. If the coefficient greater than 0, you're going to get both sides going up. If the coefficient less than 0, that means both sides going down. So let's do examples about that when we have this case. For example, if you have p of x equal 3x squared minus 4x plus 4. We're not going to graph it, we're just gonna find the end behavior. Now the first thing, the large exponents here, which is the n equal 2. This is the large exponents. That means it's even, so I'm gonna work with this side. Now I need to know which option I'm gonna choose. It depends about the number A, the coefficient. The coefficient here is a 3, which is the number beside the large exponents. So now the coefficient A equal 3, that means 3 is positive because it's greater than 0. So my end behavior, I'm going to choose the first option. That means when I'm going to graph the function, the end behavior for my function, this side goes up, and also this side goes up. I'm not going to care about here inside. Maybe it's going to be like this. The main thing, the end size for my function goes up on both sides. Goes up on both sides. The same thing if we have example like this. If we have p of x equal negative 4x squared minus 5. Let's do it x to the power 6. Minus 5x squared plus 6x. If they ask you to graph this one, 6, just 6, not 6x. So if you have function like this, and you have to know the end behavior. So the first thing I'm going to locate is the large exponent is 6, which is even number. So this one is even. So I'm going to work with this side, the even sides. Now the next step, I have to check which option I'm going to use. So I'm going to check the coefficient here, which is the -4. -4 is less than 0. So I'm going to choose this side. So when you graph the function, you have to make sure that the end behavior for your function, this side goes down and this side goes down. I'm not going to care about how it looks like here in the middle. The main thing, both my sides goes down. Both sides goes down. It means about this one, because the end behavior here, it says both sides goes down. Let's go to the next step to finish these. Then we're going to do examples about how to graph the polynomial. Before we move on, one more thing we have to learn. Sometimes you need to use extra points as you need to find the exact graph. And the last thing, there's a note if they ask you to find the turning points. What's the meaning of the turning points? We will see that. Also, the n is the large exponent. So for example, about the turning points, if you have a function like this, p of x equal 4x squared plus, let's do it a cube, plus 5x squared plus 5x minus 4. If you have this polynomial function, so n equal, which is the large exponent, 3. N equal 3. So to find the turn point, is going to be n minus 1. So it's going to be 3 minus 1 is going to be 2. That means when you graph your function, the end behavior positive, this one is going to be up, this one is going to be down. That means your function has 2 turn points. That's like that, for example, this one goes down, this is 1, and this is 2. You see, this is the first turn point, and this is the second turn point. That means the function has 2 turning points. Here's the first one, and here is the second one, and the function goes down. So that's the meaning of turning points. So sometimes when you graph the function, go ahead and make sure you got the right answer by finding the turning points. So the turning points, that mean with this example, you have 2 turning points. 1, 2. For this example, 2 turning points. We will see that when we do the first example about how to graph and doing all these steps. That's why I need to write down the steps, because we're going to do it one by one. So let's do exactly the same steps with this example. Graph the polynomial function x cubed minus x squared minus 6x. So don't confuse yourself if they're telling you p of x or f of x is the same thing, the polynomial function. So let's start doing the steps one by one. We're going to start with the first step, factor the polynomial. The first step is factoring the polynomial. So let's see with this example, how we're going to factor this polynomial. The first thing is to factor the polynomial. Here with this one, check these 3 terms, 1, 2, 3. To factor this polynomial, there's only one thing you can do it here, because it's a cube. So, but there's a greatest common factor between this one, and this one, which is the x. So I'm going to say p of x is going to be equal. Here's the x, What's the leftover? The leftover x cubed divided by x is going to be x squared, minus x squared divided by x is going to be x, minus 6x divided by x is going to be just 6. Now you see the first step, I found there's a GCF between these three terms, so I'm going to factor out the GCF here. Now I have to keep going. Can I factor the rest? Yes, because this one is a quadratic, and I can factor it by using the AC method. Let's do it here on the side about the AC method. Or you can do the other method, it's up to you. But most of the people, they're doing the AC method. So let's do the AC method here. I'm just going to write down the result. X squared minus x minus 6. This is the A1, 1 times 6, so the AC is going to be 6. We're going to factor the 6 to two numbers. We have only 1, 6, 3, 2, and 3. How are we going to get the 1? I'm going to say plus 2 minus 3 is going to be negative 1. So here is going to be x squared plus 2x minus 3x minus 6. Group these two terms, group these two terms. What's the common here is the x. X squared divided by x is going to be just x, plus 2x divided by x is going to be 2. What's the common between these two terms? The last two terms, negative 3 and negative 3. So we're going minus 3, because negative sign is also common. Negative 3 divided by negative 3 is going to be 1, so the leftover just the x. Negative 6 divided by negative 3 is going to be positive 2. We got exactly the same two parentheses. So x plus 2, and the leftover is x minus 3. So I did these steps here on the side. I'm just going to write down the result here. That means x plus 2, x minus 3. So I'm going to write down these on the side. So that means P of x is going to be equal x plus 2, and x minus 3. So I finished the first step, is factoring the polynomial. Now next step is to find the x-intercept. Step 2, we're going to find the x-intercept and the y-intercept. X-intercept, how are we going to find the x-intercept? By let y equal 0. Where is the y here? I told you before, keep in your mind, every time when you see P of x, f of x, this is the y. That means the y here on this side. This side is the y. That means we're going to let this part equal to the 0. So I'm going to plug in 0 here. So you see here, let y equal 0. That means we're going to let P of x equal 0. So I'm going to put 0 on this side. So 0 is going to be equal x plus 2, x minus 3. Now we have to move on. How are we going to find the solution? If you remember, by using zero factor property, let's do it here on the side. Zero factor property, if you remember, I told you if you have A not equal to the 0 and B not equal to the 0, when you multiply these two numbers and the result equals 0, what's that mean?
It's undefined.
No, I'm multiplying. When you multiply these two numbers and the result, this is the zero factor property. We did that on section 2.1.6 or 1.4. When you have two numbers and you multiply these two numbers not equal to the 0. These two numbers not equal to the 0, and when you multiply these two numbers and the result equals 0, that means A equals 0 or B equals 0. So one of these numbers is going to be equal to the 0. For example, We did that with the parentheses. If you have two parentheses equal to the 0, that means the first parenthesis equal to the 0 or the second parenthesis equal to the 0. We're going to use these here. That's how we're going to find the solution. I have 3 parts equal to the 0. That means 0 equal x, which is the same thing, x equals 0. X 0 equal x plus 2, and 0 equal x minus 3. The first part, I found x equals 0. Now, with the second part, I need to find the value of x. So I'm going to move the 2 to the other side. I'm going to say minus 2, cancel these. So the leftover from the right side, x, and the leftover from the left side is -2. That's mean -2 equal x, which is the same thing, x equal -2. So I found the first one, and here's the second one, the second point, the first point, the second point, x equals 0, x equal -2. The third one is going to be from here. I'm going to add 3 because we need to solve this one. Cancel these. So x is going to be equal to 3, which is the same thing, x equal to 3. Now you see we found the x-intercept when x equals 0, when x equals -2, when x equals 3. It has to be a point with x and y. The y equals 0. So I'm going to write down the first point, x equals 0, and the y equals 0. That's why it's x-intercept. The y always going to be 0. This is also an x-intercept. That means the y equals 0. So -2 and the y equals 0. This is also an x-intercept. That means y also equals 0. So it's going to be 3 and 0. So we've done the first half from step 2, finding the x-intercept. Now we're going to find the y-intercept by doing exactly the same process. X-intercept, this is the y-intercept. How are we going to find the y-intercept? By let x equal to the 0, which is this one is easier because you're going to plug in x equals 0 here. 0, 0, 0. That means p of x equal is going to be, this one is going to be 0. This one is going to be 0 plus 2. This one is going to be 0 minus 3. Let's simplify this one. P of x is going to be, or P of 0, because we're going to plug in 0 instead of the x, which is the same thing. So here is 0. 0 plus 2 is going to be 2. 0 minus 3 is going to be -3. Now multiply these numbers. 0 times 2 times -3 is going to be 0. That means P of 0 is going to be 0. P of any number here, it's the y. That means y equals 0. X equals 0, this is the y-intercept. X equals 0, the y, I got the y equals 0. That means the point here, the y-intercept is 0, 0. You see, these points are really important points because it's helped me to graph the polynomial function. The x-intercept, I got 3 points. The y-intercept, I got 1 point. We're going to use these points to graph the polynomial function. So let's do now step 3 is finding the end behavior. The end behavior now we will go back to the original polynomial function. Here's the original polynomial function. X cubed That means the large exponents here n equal 3. So I'm going to write down here n equal 3. Now we need to find the a, the coefficient. N equal 3, that means is odd number. Now I need to find the coefficient, which is the number with the large exponents. The number with the large exponents, x cubed, here is 1. That means I'm just going to write down 1. 1 is greater than 0. That means positive number. So I'm going to back to these notes. N is 3, which is odd number. A is greater than 0 because it's positive. So my end behavior for the graph, the right side is going to be goes up and the left side is going to be goes down. So this is the end behavior. This side is goes up and this side is goes down. So I'm done. I have all the information I need. I have 3 points here. I have the x-intercept. I have the y-intercept. I already know the end behavior. So now we're going to graph it. The x-intercept we have is we have 3 points. We got 0, 0. And we have the other point, -2 and 0. And the last point is 3 and 0. And we have the y-intercept. Only 1 point, which is 0, 0. Then my end behavior is this side up and this side down. So you see, this is the information I need. So now I'm going to graph it. So now let's start. I just put the x-intercept, the y-intercept, and my end behavior. That's the only I can get it from the graph. How are we gonna graph it? Let's graph the points. This is the x-intercept, which is the first point. So let's graph these points. Here is the first point, 0, 0. And the other point is -2, 0. So here is -2, 0, -1, -2. And 3, 0, 1, 2, 3. Here's 3 and 0. Now check the y-intercept, 0, 0, which is exactly the same point here. The other thing I have to do is graph the end behavior. Check, that's the important thing, the end behavior. This side, from the right side, your function, here's the last point of my function. I'm just going to graph like this, because it's telling me the end behavior on this side, the right side goes up, and the end behavior, the last point of the left side goes down. So this one goes down. That's the important thing for the end behavior. Now, my function here inside between this point and this point, we can make a guess. This one goes down, or this one goes up, then goes down, or goes up from here, or goes down from here. So we have to choose a point between these 2 points and another point between these 2 here. So we're gonna figure out the function house look like. Let's do the extra points here on the side. X, Y. I'm going to write down the polynomial function here again. Equal x cubed minus x squared minus 6x. I have purpose for writing down this polynomial function here. Now, again, I need 2 points, 1 here and 1 here. That's me. I'm gonna focus to find a point between the x-intercept here and find the points between these 2 x-intercepts. Choose a point here. I can choose -1. So I'm gonna choose the first point here, -1, and find the y is going to be up or down. So how are we gonna find -1? How much equal? We're gonna plug in -1 here. P of -1 is going to be -1 cubed minus -1 squared minus 6 times -1. So it's going to be -1 minus 1 is going to be -2 plus 4 plus plus 6 is going to be 4. So check the result equal 4. That's mean the y value here is equal 4. So let's graph. When it's -1, 1, 2, 3, 4. So it's going to be here. The extra point is going to be here. So the graph goes up and down again. That means the graph goes up here and back to this point. So the graph goes up and back to this point. So the end behavior here, I'm just going to make adjustment here. It's going to be like this, which is the same thing. Now let's check this side. I'm going to choose any point here with this graph. You can choose 1, you can choose 2, it doesn't matter. Let's choose the 2. So when x equal 2, I'm going to plug in 2 here in the polynomial fraction. So P of 2 is going to be 2 squared, 2 cubed minus 2 squared minus 6 times 2. So it's going to be 8 minus 4 minus 12. -4 minus 12 is -16. Minus 4 minus 12. 2 is going to be 8 minus 12. So it's going to be 6. Going to be -6. Let's write down -6. So -8. So when it's 2 is going to be -8. So I'm going to graph -8. 1, 2, 3, 4, 5. I'm just going to add more points. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8, so it's going to be here. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be a little bit down. With the 2, that means at 2, the y is going to be -8. So my graph from this point is going to be goes down to this point and goes back again to this point. So I'm just going to make adjustment here. Like this. So here's the graph for this function. P of the x cubed minus x squared minus 6x. Let's check the number of turning points. I'm going to do it here to make sure our graph is right. So the turning points equal n minus 1. The n, which is the largest exponent, is 3. So 3 minus 1, so it's going to be 2. That means we have 2 turning points. Let's check where's the turning points. This is the first one. You see the graph goes down, and then it turns to goes up again. So this is the first turn point, and the graph keep going up until this point. This is the second turn point, then the graph goes down. So that means we have 2 turn points. This is the first one, and this is the second one. So that's how we graph the polynomial function. So next example also they ask you graph f of x, which is the same thing, polynomial function, x minus 1, x plus 3. Be careful here with this example. So let's start here with this example, doing the first step. The first step is telling you to factor the polynomial. If you check with this example, this polynomial function is already factored. So we don't have to do step 1. That means step 1 is already satisfied because f of x is already factored. So I'm just going to say x minus 1, x plus 3 squared. That means step 1 is already satisfied. We don't have to factor the polynomial function. So we're going to go to step 2. Step 2 is to find the x-intercept. So step 2, here is the x-intercept. How to find the x-intercept? We're going to let y equal to the 0. Again, keep in your mind, f of x is the same thing, the y. This is the y. So we're going to plug in here y equals 0. That means 0 is going to be equal x plus 1, sorry, x minus 1 and x plus 3 squared. Now, next step, we need to find the value of x so we can find the value, the point at the x-intercept. Now, how are we going to find that? We're going to use the zero factor property. That means 0 is going to be equal x minus 1 and 0 is going to be equal x plus 3. Solve this one. You're going to add 1 for both sides. Cancel these. So x is going to be equal 1. So the same thing, that means x equal 1. On the other side, we're going to minus 3 from both sides. This is cancelled. So x is going to be equal to negative 3. So we already found the x-intercept. This is the x-coordinate. Here, that means x equal negative 3. We just have to write down as a point. X is 1, the y equals 0. So this is the first x-intercept. Going to do the same thing here on the other side. X equal negative 3 and the y equals 0. This is the second x-intercept. We're done from the x-intercept. Now we're going to find the y-intercept. How are we going to find the y-intercept? By let x equal to the 0. So here is the second part. Find the y-intercept. The y-intercept, how to find the y-intercept? By let x equal to the 0. So we're going to plug in x equals 0 here, here and here. That means f to the 0 is going to be equal 0 minus 1, 0 minus 1, and 0 plus 3 squared. Let's check how much is going to be the y-intercept. So 0 minus 1, that's f of 0, it means y equal negative 1. 0 plus 3 is going to be 3 squared. That means y is going to be equal negative 1, 3 squared, which is 9. Negative 1 times 9 is going to be negative 9. That means y equal negative 9. So I need to write down as a point y equal negative 9 and the x equals 0. So the point is going to be x equals 0 and the y equal negative 9. This is the y-intercept. So I'm done from step 2. I found two x-intercept and one y-intercept. I'm just going to move to step 3 to find the end behavior. So let's find the end behavior. How to find the end behavior? N equal, which is the large exponent. Here's the important thing. This is really important. Let me write down the polynomial function here, because this is really important. Where is the largest exponent? The largest exponent, because this one, the polynomial function, is already factored. So to find the largest exponent, you have to multiply all these to get the large exponents, because it's polynomial in factored form. So it's up to you. You want to multiply everything, or you want to just do these steps, because here, that's mean x. X squared, that's mean I have x squared here. There's no numbers here, there's no numbers here, so 1 times 1 is going to be 1. Now x squared x times x squared is going to be x cubed. The coefficient 1 times 1 is going to be 1. That means the largest exponent here is a cube, and the coefficient is 1. So you see, I'm multiplying the x. Here's x squared, and here's x. X squared times x times x squared is going to be x cubed. 1, the coefficient here 1 times 1 is going to be 1. That means the coefficient number here is 1. So n equal 3, which is odd, and the coefficient a equal 1, which is even. Positive. 1 is greater than 0. That means positive. So the end behavior for this polynomial function, this side goes up and this side goes down. We're done. We have 3 points, 2 x-intercept, 1 y-intercept, and I already know the end behavior. So I'm just going to use this information to graph the polynomial function. X-intercept, y-intercept, and the end behavior. Let's go ahead and graph these points. Then we will take an extra points if we need to figure out the whole graph. The first point is 1, 0. So here is going to be the 1, 0. This is the first point. The second point is going to be -3 and 0. 1, 2, 3. This is the second point. So these 2 points are the x-intercepts. Let's grab the y-intercept, which is 0, -9. 0, -9 is going to be here. 1, 2, 3, 4, 5, 6, 7, 8, 9. The last point. This is the y-intercept. So you'll see, you already know how it looks like the graph. By using the end behavior, the graph on this side goes up. The graph on the right side goes up. And you already know there is a y-intercept. So the graph goes down to the y-intercept. And the graph from the y-intercept goes to this point. We already know that from the y-intercept to this point. And to make sure, by using the end behavior, the graph on this side goes down. We already know that, up and down. Let's make sure the graph here is right. In which point, let's choose -2 as an extra point. So let's choose an extra point, -2, x, y. So choose the extra point, -2. If we plug in -2 in the function, how is going to be the result? In the polynomial function, my polynomial function is f of x equal x minus 1 and x plus 3 squared. We need to find f to the -2. So it's going to be -2 minus 1, -2 plus 3 cubed, squared. That means it's going to be -3. -2 plus 3 is going to be 1 squared. So 1 squared is going to be -3 times 1. So it's going to be -3. That means y equal -3. So at -2, the y is going to be -3, 1, 2, 3. So it's going to be here. That means at this point, the graph goes back to this point and again to here. Even if you're not finding this point, the graph is going to be from here to this point and goes back down. If you check the number of term points, n equal 3, that means n minus 1 is going to be 3 minus 1 is going to be 2. That means you have 2 term points. This is the first one, and this is the second one. So the graph, you have 2 term points on this graph. We're going to give you a graph. This is the example. This is really important. You will get a graph. This is example. They're just going to ask you, find the polynomial function. How are we going to solve this one? We have 2 steps. The first step, we're going to locate the x-intercept. So I'm going to say x-intercept. We're going to write down the points. The x-intercept, how are we going to find the x-intercept? That means the graph intersect with the x-coordinate. When the graph intersect with the x-coordinate, this is called the x-intercept. This is called also x-intercept. This one also called x-intercept. So this is the first point, which is 1, 2, 3, 4. This point is negative, 4 and 0. And this point also x-intercept, which is 1 and 0. And this point is an x-intercept, which is 1, 2, 3, -3 and 0. So I have 3 x-intercept. I'm going to write down these points here. The first point is 4 and 0. The second point is 1 and 0. The third point is -3 and 0. Check what I'm going to do here with these points. Here, it's mean x equal 4. And this one, it's mean x equal 1. And here, it's mean x equal -3. I'm just bring back the process. X equal 4, that's mean here is the point. X equal 4, x equal 1, x equal -3. Now I'm going to bring it back, the 4 to the other side. Just change the sign. So it's going to be x minus 4. The same thing here. I'm going to bring it back as x minus 1. Here, I'm going to bring it back as x plus 3. I'm done from the x-intercept. The second part, I'm going to find the y-intercept. The y-intercept, which is the graph intersect with the y-coordinate only on this point, which is 0 and 1, 2, 3, 4, 5, 6. So I have only one y-intercept. That means here on the y-intercept, the point is 0 and 6. That means f to the 0 equals 6. I'm done from the y-intercept. So here's 2 steps. The x-intercept, put down these 3 points here. Then that's mean here on the first point, x equal 4. On the second point, x equal 1. On the third point, x equal -3. I'm going to bring back the -4 to the other side. So x minus 4, here x minus 1, and here x plus 3. Just changing the sign here. Put it in the parentheses. we're done from the x-intercept. The y-intercept 0, 6 f is going to be, this is the y-intercept, only 1 point, so it's going to be f to the 0 equals 6. We're done from the y-intercept. Now here's the important part. We're going to write down the polynomial function. So here's the polynomial function. I'm going to write down the general form. So f to the x equal. I'm going to put the coefficient a. I'm going to write down all these parentheses. X minus 4, x minus 1, x plus 3. You see, I use the x-intercept on this side, put down a coefficient a in general. We're going to find this number and f to the. So I'm done now from the x-intercept. I used all the x-intercept here. Now I'm going to use the y-intercept here. It says f of x equal this part. Now f to the 0 equal. Here is the a. You see, x 0. That's mean I'm going to plug in each x 0. So each x here, I'm going to put 0. So 0 minus 4, 0 minus 1, 0 plus 3. F to the 0, only this part. So this part here. F to the 0 equals 6. So I'm going to cancel this one. I'm going to put 6 equal a. 0 minus 4 is going to be negative 4. 0 minus 1 is going to be negative 1. 0 plus 3 is going to be 3. So here is the 6 equal. Here is the a. Multiply this number. Negative 4 times negative 1 is going to be 4. 4 times 3 is going to be 12. Now I need to find the a. I need to find the a because this is the polynomial function. The only variable here is the a. So what I'm going to do, I'm going to divide. Be careful here on these steps. This one especially. You're going to divide both sides by the number beside the variable, which is the 12. You're not going to divide by 6. So when I divide by 12, this one cancel with this one. The leftover on this side is a. The leftover on the other side, 6 over 12. Can I simplify this side? Yes, divide both by 6. 6 over 12. Divide this one by 6. Divide this one by 6. So a is going to be equal. 6 divided by 6 is going to be 1. 12 divided by 6 is going to be 2. That means this is the a. Now check what I'm going to do. I'm going to bring back the a here. So I'm going to say f of x equal, how much the a? The a is 1 over 2. X minus 4, x minus 1, and x plus 3. So here is the polynomial function. Here is the solution. If you remember, because we're going to use these, if you remember, f of x equal x, the graph for this function look like just a straight line like this. F of x equal x squared, the graph of this function look like the u. F of x equal x cubed, the graph of this function, this side up and this side down. F of x equal square root of x the graph of this function is going to be like this. F of x equal the cubic root of x, the graph of this function, this side like this, and this side like this, to the left and right. The last one, f of x equal absolute value of x, the graph of this function look like v. So we're going to use one of these functions. It depends about the point. If we go back to the previous example, and let's analyze the previous example. Always check the points, the x-intercept, the graph of these points. So if you check this one, it's just a line from here and it's a curve from this side. There's no function, one of these functions similar to this graph at this point. If we check the second one, the same thing. It's just a line here and a line here. So there's no graph, one of these functions similar to this one. The third point also is just a line. So we have to check the graph at each point. So let's see the new example, how it looks like, and how we're going to use one of these points. So we're going to do exactly the same steps. Just trying to fix this one. Because this graph is not accurate. So let's do the same thing with the previous example. The first thing we did is finding the x-intercept. The x-intercept, that means when the graph intersects with the x-coordinate at these 2 points, which is here is 1, 0, the first point, and here -1 and 0. So we have 2 x-intercept. X-intercept. The first one is -1 and 0. That's mean. We're going to do exactly the same process. That's mean x equal -1. So it's going to be x plus 1. X equal -1. Then I'm going to bring back the -1 to the other side. So it's going to be x plus 1. The second point is 1 and 0. So it's going to be x equal 1. That's mean x minus 1. So we're done from the x-intercept because I have 2 x-intercepts. Now the next step is the y-intercept. The same thing, we have just y-intercept, one y-intercept when the graph intersects with the y-coordinate at this point, which is 1, 2, 3, 4, 5, 6, 7, 8. So the y-intercept is 0, -8. That's mean is going to be f to the 0 equal -8. That's it from the y-intercept. Now we're going to do exactly the same process what we did in the previous example. We're going to write down the general form for the polynomial function, which is f to the x equal a. Before we doing this one, let's go back to the x-intercept. Let's, at this point, which is -1 and 0, -1 and 0, which is this point, I'm going to check the graph at this point. The graph at this point look like this. Let's do it here. The graph at this point look like this. This is the point, and the graph like exactly like this, which is exactly the same graph for the like this, but it's flipped. So it's exactly the same graph at this point. It's exactly the same. This is a graph, exactly the same graph, but it's flipped. And this graph is the graph of this function, which is the x squared. That means I need to square this point. So I'm going to put square here. That's why we have to analyze the graph to get the polynomial function. I'm going to do the same thing on the other side. Also, this side at this point is the graph exactly the same thing like this, which is the graph. This is exactly the same graph like this, which is the graph of the x squared. This is the graph of the x squared. So that's mean I'm going to square this point too. This is really important. So now, when I write down the general form for the polynomial function f of x equal a, I'm going to write down these with the squared. So x plus 2 squared and x plus 1 squared and x minus 1 squared. I'm done from the x squared now. Now I'm going to use the y-intercept. It says f of x equal this one. Now it says f to the 0 equal. I'm going to plug in 0 instead of each x. So it's going to be a 0 plus 1 squared, 0 minus 1 squared. Now f to the 0 equal negative 8. So I'm going to write down negative 8 here, and here is a. 0 plus 1 is going to be 1 squared. 0 minus 1 is going to be negative 1 squared. So it's going to be negative 8 equal a. 1 squared is 1. Negative 1 squared, which is negative 1 times negative 1, is going to be 1. So here's negative 8 is going to be a times 1 times 1 is going to be a. So I found the value of a. I'm just going to plug in the value of a back here to get the result. That's mean f of x is going to be equal a, which is negative 8, x plus 1 squared, x minus 1 squared. This is the graph of the polynomial function. So this is the polynomial function for this graph. So here's another example about finding the polynomial function from the graph. So we're going to do exactly the same steps. The first step is the x-intercept. We're going to find the x-intercept. Here's the first x-intercept, which is the coordinate for this point, negative 2 and 0. So I'm going to write down negative 2 and 0 here. Yes, we don't have to write down here. Negative 2 and 0. And this point is 1, 0. So the first x-intercept is negative 2 and 0. That's mean x equal negative 2. That's mean x plus 2. The second x-intercept is 1, 0. So I'm going to say 1 and 0. So x equal 1. That's mean x minus 1. So these 2 points are the x-intercept. Before we move into the y-intercept, you can analyze the graph at each point. Where is this point? Negative 2 and 0. Check negative 2 and 0 is just a line from the top to the bottom, just a line. It's not a line crossing here, the origin point. It's a line like this. So if you check these 6 graphs, we have it. there is no function, one of these similar is just a line like this. No, there is no function similar to this one, so I'm not going to do anything with this point. Let's check the other point, this one. Check this point, which is 1, 0. That means the other point, which is 1, 0. The graph for this point here, similar to this one, similar like this up, this side is up, and goes like this and like this. If you check this graph, we have a function similar to this one, but it's flipped like this. We have a function like this. So if you check that, we have a function like this. So that means this function, this graph is similar to this function at this point, but it's flipped. Which function this one? Let's go back to the graph. You see, this side up, this side down, which is this one is the cube. That means this is the graph of x cubed. So this graph similar to the graph of the x cubed, but it's flipped. This side flipped to the right, and this side on the right flipped to the left. So that means at this point, we have to cube here. Put the cube here. Now we've done it from the x-intercept. We analyze the graph at these 2 points. Now, the y-intercept, we have the point here, which is 1, 2, 3, 4, 5, 6. The point 0, 6. So the y-intercept we have only one point, which is 0, 6. That means f to the 0 equals 6. So we're done from everything. Now we need to write the general equations for the polynomial function. F of x equal a. I'm going to write down these. X plus 2, x minus 1 cubed. Then after that, I'm going to use the y-intercept. That means I'm done from the x-intercept. I'm going to use the y-intercept here. So f to the 0 equal. Plug in instead of each x 0. So it's going to be a 0 plus 2, 0 minus 1 cube. F to the 0 equals 6 equal a 0 plus 2 is going to be 2. 0 minus 1 is going to be negative 1 cubed. So here is 6 equal. Here is the a. Here is the 2. Negative 1 cubed is going to be negative 1 times negative 1 times negative 1, which is negative 1. Now here is the 6 equal. Here is a. 2 times negative 1 is going to be negative 2. Last step, you're going to divide both sides by negative 2 by the number beside the variable. Don't do mistakes. Cancel these. So the leftover from the right side, a equal 6 divided by negative 2 is going to be negative 3. So this is the value of a. We're going to plug in a back here to write down the solution. So the solution is going to be f of x equal a is negative 3, x plus 2, and x minus 1 cubed. This is the general form for the polynomial function for this graph.